what is the end term for each sequence below? Here we have three sequences, and the objective here is to find that explicit formula that describes the sequence. So for the first one, we have 3, 5, 7, and 9. So understanding how sequence work actually helps us find that explicit formula that we're looking. Now here we can see that the difference between two succeeding terms is equal to 2, which means that the first sequence is what we call an arithmetic sequence. So to find that general formula for the sequence, all we need to do is to use that formula in finding the indicated term of an arithmetic sequence. So that's this one, a1 plus t times n minus 1. And what we will do here is simply substitute or find a1, which is the first term, and d is common difference, and then simply simplify the given algebraic expression or the formula. a1, like what I said, is the first term, that's number 3, plus d, which is the common difference, that's number 2. N will stay n, and simplify this. Okay, distribute that 2n minus 1, 2 times n minus 1 rather. So that's 2n minus 2. Combine the constant numbers. So that's 3 minus 2, which is equal to 1. So the general formula for the first one is 2n plus 1. Let's answer the second sequence. Now here, 2, 4, 8, and 16, if we try to find the difference of any two succeeding terms, we will notice that they're not equal. All right? Okay, so that's 2, 4, and 8. So what are we going to do? What's our next option? The next option is you need to find, or you need to understand the sequence. So ask yourself, what do you think is the next number on the sequence? Okay, that's correct. It's 32. So to find the next number on the sequence, what we simply do here is simply multiply that number to 2, or to double that number to get the next number. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is etc., etc. So we're talking about here a sequence that has a base of 2 raised to n, right? So this is 2 raised to 1, this is 2 raised to 2, 2 raised to 2 is 4, this is 2 raised to 3, 2 times 2 times 2, which is 8. This is 2 raised to 4, it's 2 times 2 times 2 times 2. So now that we understand that, and we have there the 1, 2, 3, and 4, we can clearly see that the formula that, or the nth term formula that describes the sequence is 2 raised to n. Okay? The last one, we have 1, 1/2, 1/3, 1/4. Now you might be thinking, okay, the first one is a whole number, and the rest are fractions. Actually, we can express the first term as a fraction so that it will be clear to us what is the sequence all about. We can say that this is actually 1 over 1, 1 over 2, 1 over 3, 1 over 4. Now, we can now guess the next term. It's going to be 1 over 5, and then the next is 1 over 6, 1 over 7, and so on and so forth. And then the numerator will always be 1. So since the numerator will always be 1, I will put the 1 there. And then how are we going to describe the denominator? You start with 1. So if n is 1, it's 1 over 1, which is 1. If n is equal to 2, it's 1 over 2. If n equals 3, 1 over 3. So which means that this is just 1 over n. So if you replace 1 by, or n by 1, that's the answer, the first term of the sequence. If you replace that n by 2, that's the second term of the sequence, etc., etc. So in finding the general formula of a given sequence, there are so many things you have to consider. But the most important thing is understanding how the sequence works. And that is, try to guess the next term of the sequence. And from there, you'll be able to find the formula that describe the sequence.